In example 3, we're going to use the idea of multiplying by the conjugate, which is just an algebra skill. So we'll get it set up. We have our statement and our rule. So if we take a look at this left-hand side, we have sine of beta over 1 minus cosine beta, and on the right we have cosine beta plus cotangent beta. Now you could work with either side right here. There's not really a right side or a wrong side to work with. One thing that you could notice is that on this left-hand side, because we have the 1 minus cosine beta and it's not squared, we can use that idea of the conjugate that we talked about in section 5.1. So let's go ahead and try that. So we're going to do sine beta over 1 minus cosine beta, and what we're going to do is we're going to multiply that by the conjugate, which is 1 plus cosine beta over 1 plus cosine beta. And the rule for that is just algebra. Number 2, we're going to go ahead and multiply these together. So I have sine beta times 1 plus cosine beta. And then if I multiply those out on the bottom, that's a difference of squares again, and I get 1 minus cosine squared beta. Step 2 just being algebra. Then in step 3, if I take a look at my denominator, again, multiplying by that conjugate is giving us most of the time that Pythagorean identity we're looking for. And 1 minus cosine squared beta comes from our Pythagorean identity that sine squared plus cosine squared is equal to 1. And so 1 minus cosine squared is just sine squared. So I have sine beta times 1 plus cosine beta over sine squared beta. And what I did here, again, is I changed the denominator to sine squared using a Pythagorean identity. In step 4, I can look and see that I can simplify a little bit. I have a sine beta on the top, and I have 2 sines on the bottom. Remember, sine squared is a sine times a sine. So I can cancel out 1 on the top with 1 on the bottom, leaving me with 1 plus cosine beta over sine beta, and that was just an algebra skill. Then if I go down, step number 5, now I have that trick that we did back in 5.1 where I have 2 things that I'm adding on the top with the same denominator. So I'm going to go ahead and split that up. Okay, I'm going to go backwards, and let me refresh your memory one more time with that. So just think about really quick, we had something like 5 over 2 plus 3 over 2 is the same thing as 5 plus 3 over 2. So we're looking at this and we're going backwards. Remember, both of these things come from having a denominator of sine in order to get them together. So we can go back and split them up. So I'm going to have 1 over sine beta plus cosine beta over sine beta. And that rule here is just algebra. My next step, step number 6, I'm going to go ahead and I'm going to change one of these at a time since they're different identities. I can do my 1 over sine, which is going to be a reciprocal identity, so I can change that to cosecant of beta. Plus I still have my cosine beta over sine beta. And that rule for number 6 is reciprocal. And I have one more rule. One more step here. I'm going to put that right here. Number 7. Now I can change my cosine over sine. So I have cosecant beta plus cosine over sine is cotangent beta. And that was using my quotient identity. So I have now proven that my left-hand side is the same as my right-hand side. If you have questions, let me know. Otherwise, I'm going to go ahead and show you the rules or the steps for the next one. So pause it now and give it a try, and then you can check your answer when you're done. If I set this one up, I'm going to do the same as I did before in the start, which is multiply by that conjugate. So step number 1, I'm going to take my tangent of x over secant x plus 1, and I'm going to multiply by secant x minus 1 over itself. And that's just an algebra rule. Step number 2, I'm going to go ahead and multiply the top and the bottom. So I'm going to take tangent of x times secant of x minus 1. And multiplying out the denominator, which is a difference of squares, is secant squared x minus 1. And step 2 here was just algebra stuff. Step 3, I can use my Pythagorean identity. The secant squared x minus 1 is just tangent squared x. So I have my top the same, tan x times secant x minus 1. And I'm going to change the bottom to tangent squared using that Pythagorean identity. Then in step 4, I can look to simplify. I have a tan x on the top, and I have two tans on the bottom, so I can take one of those out. And that leaves me with secant x minus 1 over tangent of x. And that rule being algebra. Now I'm going to have to come over here for step 5. So let's get this written up here again. We have our statement and our rule. So we are on to statement number 5. And in statement number 5, I'm going to go ahead and do that same trick we just did in the example above, where I can split up secant x minus 1 over tangent x into secant of x over tan of x minus 1 over the tangent of x. And that was just algebra. Step number 6, I'm going to go ahead and I'm going to change. I have to change both of these. I can change one at a time. I'm going to go ahead with my tangent of x, or 1 over tangent of x. I can change that to a cotangent of x. So I have secant x over tangent of x minus cotangent of x. And that's my reciprocal identity. And then in step 7, I can change my secant over my tangent isn't an actual identity, so I'm going to split these two up, and I'm going to look at the secant of x divided by tangent of x. And I still have my minus cotangent x, and this is just algebra. Sorry, I'm running out of room here. Step number 8, I'm going to change my secant to 1 over cosine. And I'm still dividing by tangent of x minus cotangent of x. And this is my reciprocal identity. Step number 9. Now I'm going to go ahead and change my tangent to sine over cosine using my quotient identity. So I have 1 over cosine x divided by sine of x over cosine of x minus cotangent of x. And that I used my quotient. Then I can go and look at step number 10. And I'm going to change my division to multiplication. So I have 1 over cosine of x times cosine x over sine of x minus cotangent of x. And step 10 here was just algebra. Step number 11, I can go ahead and cancel out my cosine x's here. And that leaves me with 1 over the sine of x minus cotangent of x. And that's just using algebra. And then finally in step number 12, I can use my reciprocal identity to change 1 over sine x to cosecant of x minus cotangent of x, which is what I needed to prove. And so step number 12 here, this was my reciprocal. If you have questions, let me know.